Okay. In my example, iron reacts with hydrochloric acid to produce iron 3 chloride. So the first thing that we need to do is to write down the equation, which is going to be the equation. Iron, which is Fe, yes, reacts with HCl, good, hydrochloric acid, to produce what? Iron 3 chloride, which is the formula. No 2. The chlorine is -1, so we need 3 times this, and that's it. That is the iron 3 chloride. Plus hydrogen gas. And the hydrogen is diatomic, meaning 2 atoms in the molecule. Now, once we have these, we need to balance the equation. How do we do that? We have 3 chlorines here, but if I multiply this by 3, the hydrogens are going to be only 3, and I have this a pair number. So it's good for me if I multiply this by 2. How many chlorines I'm going to have? So I put a 6 here. So I have 6 chlorine. And what happened with the hydrogen? So we need a 3 here. Yes? And there is anything that is not balanced? The iron, be careful with that, okay? You need to verify that everything is balanced. Now, second step. We need to calculate the masses, the molar masses. Again, I'm going to do it like this. Okay, so first for the iron. The iron is alone, so the molar mass is the same as the atomic mass expressed in grams. So in this case, it's going to be 56. Yes? If you take the periodic table, you're going to see that it's 66. Now, I'm sorry, 56. Now, how many times we have the iron? Twice. So we need to multiply that 56 times 2. Do you understand? Because we have 2 more, so it's going to be, I'm going to put, because it's an example, 2 times 56, so you remember what it is. But we are going to use these numbers, 112. And this is iron, of course. Every mass that I put corresponds to the element that is just above. Now, hydrogen chloride. I have hydrogen and I have chlorine. The hydrogen is 1, the chlorine 35.5. That is the number that we use in Cambridge. So the total is going to be 36.5. And I have 6 times that. Do you see the 6 here? So it's 6 times 36.5. Can somebody do the math for me, please? Huh? I cannot hear you. 219 grams of hydrogen chloride. Do you understand what I'm doing? Yes? Now, we need to calculate this one. And this one is going to be chlorine, which is 35.5 times 3. So 3 times 35.5. And the iron is 1 times 56. Can somebody tell me 35.5 times 3? 116? I cannot hear you. Okay, 6.5. And this is 56. So it's going to be 161, no, 62. 160, oops, 2 times 162.5. Okay? And I'm going to erase this here. Now, the last one is the easiest one. How much is this? Someone that picks up. 2 times 162.5. 325 grams of iron chloride, iron 3 chloride, plus 3 times 2 is 6, so it's going to be 6 grams. So it's 3 times 2 grams, 6 grams of hydrogen. You're going to say, how much work we have to do for each one? Yes, that is good. Why? Because if you add this one, the masses of the reactants, they have to give you the same as the mass of the products. If something is wrong there, do not go on, because all the calculations are going to be wrong. Okay, so you need to verify that before doing any calculations. So once we calculated the amount of masses with the moles. Okay, so this one is, by the way, 162.5. Okay, now what did we do when we calculate any of these problems? We were putting the question in the form of a fraction, yes? We're going to do the same thing. It says, how many grams of hydrogen gas? So I'm going to put how many grams, the unit of hydrogen gas, I will obtain with what? Yeah, because we are doing the first one, okay? 30 grams of iron. Again, the same procedure that we did before. We are going to make a line, and here I'm going to put grams of hydrogen, and here I'm going to put grams of iron. Now, where I'm going to get these numbers from? From the highlighted part, okay? So I need grams of hydrogen. I go to the highlighted part and I look underneath the hydrogen how much is the grams, and I put it here, 6 grams. Yes? And how much I'm going to put here? 112. Why 112? Because if you see in the 112 are the ones that I have here, and 6 are the grams of hydrogen that I have here, because this is the hydrogen and these are the iron, and that is what I need to do. And then it's just cross multiplying. Okay? So then again, if you don't remember, just in case, if you make a line here, everything that is on the line is going to be multiplying and the other ones are going to be dividing. So X will be the same as 6 grams of hydrogen times 30 grams of iron divided by 112 grams of iron. Do not put grams only, because I can cancel only grams of iron with grams of iron. I cannot cancel grams of iron with grams of hydrogen. Okay, so as to be sure that the things are correct. Now X is equal to 1.61 grams of hydrogen gas, and that is going to be your answer. Okay, so the longest part is calculating all these. Once we have all these, this is shorter. Okay, now do we need to do this and show everything? No, the only thing that you need to show is the part that is highlighted, meaning that you know how to calculate the masses of each of these ones. That is the only thing that I require. Then if you calculated this correctly, it's going to be 1 point. If you show me the proportion correctly with units, it's going to be another point. For the number, you're going to have another point, and for the unit here, you're going to have another point. In total, 4 points. You are missing one of them, you are missing that point. Yes? Now, instead of using this here, I'm going to show you how to use the same numbers that we have here. So instead of writing down everything again, I'm going to erase just the part that I don't need. What? Yes. You can, if you made all the calculations, and the molar masses, I mean, that you need to calculate, they need to be correct. Okay, now I'm going to show you a shorter version of these. Okay, it's the same, but it's a little bit shorter. Instead of writing down the fraction, the question in form of a fraction, I'm going to write down the question here. How I'm going to write down the question here? I'm going to put it in another color so you can make a difference between one and the other one. I'm going to say, if you start with 30 grams of iron, where is the iron located? Here. So I'm going to put below that 30 grams of iron. Yes? Grams of iron, grams of iron. Is that okay? Now, it says, if you start with 30 grams of iron, how many grams of hydrogen I'm going to obtain? So I'm making below the hydrogen, I put another line. Now look at this. If I go here and I look grams of iron, and I have this one, grams of hydrogen and grams of hydrogen, and I put this equal to that one, you have a word proportion, exactly the same that we did before. The only thing is that they are in different order. But if I say, I'm going to do it without the units so I do it faster, okay? 112 divided by 30 is equals to 6 divided by x. Isn't that the same numbers that we calculated just a minute ago? X equals to 6 times 30 divided by 112. Can you do it like this? Yes, but you are not going to get the points for the units. Okay? Now, we are going to see the second part, but in another video.